Equivalent rates are interest rates that look numerically different and are compounded differently, but yield the same result or maturity value when the same amount is invested for the same amount of time. You can convert interest rates to an equivalent interest rate using the Texas Instruments BAII 2+ financial, as well as manual computation using math, either first principles or using the formula. The theory is that equivalent rates are equal, so we find the future value of $1 for 1 year and make them equal. $1 for 1 year is the easiest, so we choose that for our formula. You can solve by first principles, i.e. $1 for 1 year, or you can use the formula derived from that, which is F equals 1 plus I to the exponent M1 divided by M2. F is the new equivalent periodic rate, which I will call the target rate. M1 is the compounds per year for the starting rate, and M2 is the compounds per year for the target rate. For example, convert 8% compounded yearly, i.e. effective, to the equivalent rate, which is the target rate, compounded monthly. Using the formula, F equals 1 plus 8% divided by 1 for 1 year to the exponent 1 divided by 12. M1 is the starting rate and M2 is what we call the target rate, minus 1. This equals 0.64340,301% per month. Multiplying by 12, we get 7.720836% compounded monthly, which is the nominal interest rate. Here are some examples. Number 1, convert 7.5% per year compounded semi-annually to the equivalent interest rate compounded yearly, i.e. the effective interest rate. Manually, from first principles, $1 for 1 year. The target is the effective interest rate or the compounded yearly interest rate. So we invest $1 times 1 plus F to the power of 1 for 1 year is equal to $1 times 1 plus 7.5% divided by 2, because it's 7.5% compounded semi-annually, to the exponent 2, since there are 2 semi-annual periods in 1 year. Working this out, we get F equals 1.0375 squared minus 1, which gives 7.640625% every year. So 7.5% compounded semi-annually equals 7.640625% compounded yearly, or the effective rate. The formula gives the same result. If we bring up our calculator, these are the calculator key steps. Second function, interest conversion, clear the menu, second function, clear work. The nominal interest rate is 7.5% per year compounded semi-annually. So we press 7.5, press enter, press the up arrow to compounds per year. Semi-annually is twice per year. Press 2, enter, press the up arrow. We get to the effective window, press compute. The answer is 7.640625% compounded yearly or effective. Next question, convert 9.75% per year compounded quarterly to the equivalent interest rate compounded semi-annually. We are going to do this from first principles, $1 for 1 year. 1 plus F to the power of 2 is equal to $1 for 1 year at 9.75% to the power of 4, since there are 4 quarters in 1 year. $1 for 1 year. Solving F, we get 4.9344141% per 6-month period. Multiply by 2 to get 9.868828125% compounded semi-annually. This is the nominal interest rate. So 9.75% compounded quarterly is equal to 9.868828125% compounded semi-annually. Again, let's bring up our calculator. Clear, we're going to start from the beginning. Second function, interest conversion. Second function, clear. We want to start with 9.75% compounded quarterly. press 9.75 in the nominal window, press enter. Up arrow. It's compounded quarterly, press 4, enter. Up arrow. We are at the effective window. Press compute to get the effective interest rate, which is 10.11231255% compounded yearly. We don't want that. We are looking for the compounded semi-annual rate. So we need to press the down arrow to go back to compounds per year. Change it to 2. Press enter. Down arrow back to nominal. Press compute. And we have our solution 9.868828125% compounded semi-annually. So 9.75% compounded quarterly is equal to 9.868828125% compounded semi-annually. Using your calculator, you must first go to effective if you want to go to a different compounding period other than effective. Example 3. Convert 6% per year compounded monthly to the equivalent interest rate compounded quarterly. If we use our $1 for 1 year first principles, it's $1 times 1 plus f to the power of 4 because we are looking for our target of compounded quarterly, $1 for 1 year. This is equal to 1 plus 6% divided by 12, since we are converting 6% compounded monthly, to the power of 12, $1 for 1 year. Solving for f, we get f equals 1.005 to the power of 12 divided by 4 minus 1. Solving for this, we get 1.507512% per quarter. This is the periodic interest rate. We multiply it by 4 to get 6.03005% per year compounded quarterly. Therefore, 6% compounded monthly is the same or equivalent to 6.03005% compounded quarterly. Let's use our calculator. Press clear. We'll start from the beginning. Second function, interest conversion. Let's clear our menu. Second function, clear work. We want to convert 6% compounded monthly. So press 6 under the nominal menu. Enter. Up arrow. Compounded monthly. We change the compounds per year to 12. Press enter. Up arrow. Press compute to get the effective rate or the yearly rate. We're looking for compounded quarterly, so we need to change this effective rate back to quarterly. Press the down arrow button. Change the compounds per year to 4. Press enter. Press the down arrow and press compute under the nominal window to get 6.03005% compounded quarterly. Last example, convert 10% per year compounded yearly or effective to the equivalent interest rate compounded monthly. The target rate is 1 plus f to the exponent 12, since there are 12 months in 1 year, which is our target rate, is equal to 1 plus 10% to the power of 1, since there are 1 year in 1 year. F is equal to 1.10 to the power of 1 divided by 12 minus 1. This gives us 0.797414043% per month. Multiplying by 12 gives you 9.568968515% per year compounded monthly. This is the nominal interest rate. So 10% compounded yearly is the same as or equivalent to 9.568968515% compounded monthly. Again, using our calculator, I'll start from the beginning. Second function, interest conversion. Second function, clear work. We start with 10% per year compounded yearly, or the effective rate. The easiest way to do this is to go directly to the effective window. Press the up arrow twice. Press 10%. Press enter. Press the down arrow button to go to compounds per year. We want to change this to compounded monthly. Press 12. Enter. Press the down arrow button. Under the nominal window, press compute, and we have our answer, 9.568968515% compounded monthly.